Subramanian, are you there? Vasant, can you brief about yourself? Parvesh? So you can able to hear me, right?
Hi, hello. Am I audible?
Yes, Parvesh. Yeah, you can go ahead.
Hi, everyone. I'm Parvesh Sarkar. I'm from Pune. Currently, I'm having an experience of 1.5 years as a data engineer and currently working in Data Fortune Private Limited as an operations team member.
Okay, got it. Jashwant?
Yeah, hi Ganesh. Myself, currently working as an data ops engineer. Previously, I have been working as a AWS cloud engineer, where I worked on other services like networking and stuff. Currently, I got a chance to work as a data ops engineer, and here I was supposed to work with AWS data services like Glue, EMR, and such stuff, and a bit PySpark, Python, and SQL, and Airflow with Snowflake, and as well Snowflake. Such kind of tech stacks are there here. So I would like to explore a bit on this, and would like to transition and I would like to transition my career from data ops to data engineer, AWS cloud data engineer, like that. That was my goal towards by this course actually.
Okay, got it. Thank you. Thanks for your time. And
Yeah.
Venkatesh?
Hi, myself Venkatesh. I have experience of 9+ years and relevant to data engineering. I have 2+ years of experience. Before I was working as a full stack developer, Java, React, and now I am working as a data engineer. And I have experience in Azure. Now I need to learn more about the AWS. So I'm looking for it.
Okay, got it. Thank you. And Vasant? Subramaniam? Vasant and Subramaniam, can you brief out yourself?
Hello.
Yes, Subramaniam.
Hello.
Yeah, you can go
Yeah.
ahead.
Hi. I am a recently graduated, so I was learning. I mean, starting my career in data engineering. So I chose the path to learn about the data, Hadoop, Spark, that how the data is going. So it's basically just I want to start my new career in data engineering. So just I want to learn everything that from the basic.
Okay, thank you.
Yeah.
And yeah, Vasant, you can go ahead. Vasant, we are not able to hear you. Can you check your mic or something? Raju?
Hello,
Yeah, Raju, can you brief out yourself?
yeah, myself Raju, and I have been working for last 4 years in the Python domain in the backend part, and some parts of in AWS cloud. Mostly my working part is developing APIs for the backend using Python, Django, Fast API, and AWS Lambda API Gateway, S3 and DynamoDB. So this is the backend part. I have been working for the last 4 years.
Thank you, Raju. Yeah, Aditya, you can go ahead.
Thanks, Ganesh. Thanks everyone for joining. A very warm welcome to the first demo session about our data engineering course, right? Let me introduce myself. My name is Aditya. I'm having 8 years of experience predominantly into data engineering and machine learning space. So I have experience with microservices, batch, or real-time data engineering processing, and post that how we can utilize this data to generate meaningful insights out of it, and then applying the machine learning model and algorithms on top of it to take business driven intelligent decisions that can help business move forward. So I've been fortunate to work with Fortune 20 organizations. So that's a quick brief about me. I am good with Python and SQL. So this course that we are going to take on will be focused mainly on SQL and Python as well. And predominantly the course will be based out of AWS. And for doing the processing, we are going to use PySpark or say Spark as our processing engine. Right. That's a quick bit about me. I'll quickly start the presentation for today. It's going to be a very brief presentation, what exactly we are trying to do. And then I have one or two quick demo. If time permits, I'll try to do a quick demo of what all cloud capabilities we can exercise to do a lot of interesting stuff with data engineering space. Okay, with that, let me quickly share my screen. Okay, I'm sharing my screen. Guys, just confirm once the screen is visible to you all.
Yes, it is visible.
Awesome. Right. So as you guys already be knowing that the course predominantly focuses on AWS data engineering, or if I have to say data engineering on AWS, right? So before we go deep dive into data engineering, or before we go deep dive into what all topics we are going to cover, how the things will be covered, I just want to set a tone for everyone available on the call, because I see a wide variety of diaspora available on the call, starting from freshers and having a very good 9-10 years of experience, right? Okay, so let's break down this into three pieces. One is AWS, one is data, and third thing is engineer or engineering, right? I'll start quickly, first of all, with data, right? So what is data? So any information lying around in front of us, right, is called data. Data can be in any shape, any format. It can be in a form of a table, right, where you have rows and columns. Data can be in a form of a JSON array. Data can be in a form of a audio, video, text message as well, right? All of the data is available out there, and organizations are using this data to make meaningful decision out of it, right? So all of us will agree that the amount of data which was getting produced, say 10 years back, say before the era of social media, and the amount of data which is now getting produced has increased exponentially, right? I hope everyone agrees with this point. The amount of data that we are producing 10 years back and the amount of data that we are producing today has increased many folds. And if I have just to give you one number, like how much it has increased. So the research which has been published, it says that the amount of data that we are generating in a year, that we were generating in a year, 10 years back, is almost equivalent to the data that we are generating within a day itself, right? And you can witness this, the amount of videos, the amount of short reels, right? The number of posts people are making, right? The number of online users which are growing, the orders which are happening online, right? Everything has increased manifold, and which in turns gives lot of data, which produce lot of data. So which means that there is lot of data lying in front of us. It's a pool, it's a sea, and organizations want to harness the power that they can get from this data itself, right? So to harness the power of this data, they need someone, right? Because there lies the data, and they need somebody to understand what the data is, process what the data is, and generate meaningful information out of it. And that process, and the guy who does this work, we basically call that person as a data engineer, or this process we call it as data engineering, right? So if I have to sum it up in simple small words, you have a lot of data. If you want to generate meaningful information out of it, you need to process that data, and that data processing by building data engineering pipelines is basically done by a data engineer in simple layman terms, right? So this is what, in simple term, data engineering is all about, right? So I spoke about taking informative decisions from the data, right? What exactly it means, right? So let's imagine there is a food chain company, right? Say McDonald's or Pizza Hut or Domino's. They want to start a new product in a country, right? Because they are available across multiple countries, right? So they will start a new product, but before starting a new product, they have to do a lot of research, right? So for example, if they want to start a product in India, they need to understand what is the price consumption or price sensitivity of Indian customers is, right? So if they launch a burger, I'm talking about, let's say, McD, and if they launch a burger of price 2000, then it may not be a good product, a good fit for them, because Indian customer buying habits on burgers normally like around 50 rupees till 200, or at max it can go up to 300s, right? Nobody will buy a burger of 1000 rupees, especially from McD, right? So how do they decide the price? To understand the price and everything, they need to understand the buying pattern of Indian population. How exactly they can understand the buying pattern of Indian population? Because they have the data. How they have the data? So if you are, try to recall, whenever you go to MACD, you go over there, right? You purchase something, they create an order for you, right? And they give you a bill. Automatically, that information sends back to the server of MACD, right? And this happens every day, every minute at each and every stores, right? MACD has, if I'm not mistaken, more than 500 store across India, right? And if they do 100 orders per day, imagine how much data per day they are generating. And encountered this over a period of 5 years, 6 years, because that is where MACD is living in India itself, right? So how much data they have generated. So if they have to just do a quick insight, okay, tell me the average buying price of Indian customer. With this data, they can easily identify this, right? Similarly, if they have to identify the percentage of veg food preference versus non-vegetarian food preference, they can identify that, right? They can also identify the clusters in which products sells best. For example, in some cluster, a combination of Coke plus a combination of Pepsi plus burger plus fries go more, compared to in some area where only a burger go more, right? So they can understand all of this insight from their data, but how they can understand this insight? So they need someone to process this data end to end, starting from collecting from the source, transforming it, and finding the meaningful answers from the data, so that a informative decision can be taken out, right? So after doing this analysis, let's say the analysts find out that the average selling price is optimal price is 120 rupees. So if MACD has to launch a new product, next time they place the product with price say 130, 140, 110, something in that range itself, so that the customer has more tendency to buy the product without any hesitation of, thinking about the price itself, right? So this kind of decision can be taken if we have good data, and if we have proper data processing, proper data pipeline is done, right? This is just one very simple example of what power, what insights data can bring. There are millions of such examples, instances available out there, right? So probably everyone has seeing Instagram reels. Probably everyone is seeing YouTube shorts, right? So how you see the dynamics of these reels change over a period of time. They utilizes our seeing pattern. They understand our how much seconds we are giving to a reel, and accordingly they prescribe us more reels, so that your watch time on their product increase, so that they can show you more and more ads, and in turns generate more profit, right? Because at the end of the day, for social media customer, we are the actual uh, money earning source for them, because they are not charging us any money. So how they are generating money, right? So they are generating the money by selling us to the advertising um, platforms, so on and so forth, right? So I'm just giving few instances of how data is there, how it can be utilized to take meaningful instance, and how organizations, the big organizations, are taking decisions, right? If I have to name it, Walmart, right? If I have to name it, Apple. If I have to name it, uh, Facebook, right? Instagram, Twitter, right? Multiple organization, every organization is utilizing the data and then generating insights, and then accordingly positioning their product to generate more and more profit. That's what organizations are doing, right? And hence the importance of data engineering in this world, right? So everything which I have mentioned here talks about what exactly data engineering is. We have discussed quite a bit already, right? So what exactly data engineering is? It's all about building and maintaining the infrastructure for storing the data, processing the data, and ultimately loading the data so that meaningful decisions can be made out of that data. What is the responsibility of a data engineer normally? To collect data from various sources. Sources can be a file, source can be a database, source can be a API, source can be a social media platform, so on and so forth. Further transforming it, right? And then storing it back by building data pipelines and by building data warehouses, data lakes, and so on, right? What are the challenges that a data engineer can face or see? It's about scalability, right? Let's say a data engineer has built a pipeline that process 1 million records per day. But going forward, the company's need has increased. Instead of 1 million, they want the data to be processed 10 billion records per day. So how you manage your pipeline, how you scale your pipeline to handle the large scale data, that is what few challenges data engineering faces, right? Apart from that, data governance, data quality, real-time processing, how you are going to process real-time data, meaning as soon as some data comes, you want to process it and sends the information back, right? So these are the few things that data engineer faces in their day-to-day life, and we are going to talk about all of this in detail in our program, right, that we have built for you. Then what all different tools data engineers uses, right? So predominantly for data storage, they uses AWS S3. For data processing, they uses Apache Spark, or say a few other tools of this similar lines. Then for data warehousing, they uses AWS Redshift. For automations, they use Airflow. For storing their data, they predominantly can use Snowflake as well, right? So there are various tools that a data engineer can use in their day-to-day life, and all of these we are going to cover in our future sections, right? I'll quickly jump on to the third thing, right? The third word, because if we break down this term, we have discussed data plus engineer or engineering already. Then we just need to discuss what exactly AWS is, right? So AWS stands for Amazon Web Services. It's a cloud provider that provide cloud solutions for organizations to host their data needs, to fulfill the data processing requirements, so on, right? Let's first of all understand what exactly cloud is, and then we'll try to understand what exactly AWS does and how AWS help us in doing data engineering, right? Okay, let's first of all understand what exactly cloud is. So so the image which I am highlighting with the red border, right? It's not the cloud that we are going to learn and talk about in our classes. So cloud is a server, is a set of different computers and machines that are located very far away from our reach in a very secure and very protected environment, right? So the picture on the with the green border is the cloud that we are going to learn, not the one, with the red border itself, right? So it's a basic definition. If I have to give you an example of cloud that everyone has used in their life, that could be Gmail, that could be Google Drive. Google Drive is one of the best example of clouds that everyone has used, right? So what is the characteristics of Google Drive, right? So can you touch Google Drive, right? Can you see where exactly Google Drive is located? No, right? What we can do is we can store our photos, video, and documents in the Google Drive. And where exactly these photos and videos are stored? Are they stored in our mobile phones? No, they are stored in a highly secured, highly protected environment. In that environment is called cloud. And who provide that cloud space? Google provides that cloud space for us, right? Which means that if, let's say, I have 10 photos in my mobile phone, I have uploaded those 10 photos to the Google Drive, right? Somehow my phone is stolen and I want to access those photos again. So I need not to, search for my phone. What I can do is I can just log into Google Drive and access those photos again, because these photos are safely secured over the cloud, right? So this is what basically a basic example of cloud is. There are various types of cloud available in the market, right? This is just an example of storage type of cloud where you can store your data. your photos, but there are advanced cloud which provides various features to different companies and organizations from the not only from the storage standpoint but also from the processing standpoint, right? I'm going to talk about what exactly processing is in a few minutes, right? Now the question is why our course is basically designed on the AWS cloud tech stack. So if you look at the graph on my right side, this is a graph, or this is the statistic which is published by Statista. So Statista is one of the prominent data collector, right? So they are leader in the market for doing research, and as per their research they estimates that AWS is leading the market share, right, in terms of demand from the processing standpoint, also from the job standpoint. So which basically means that the number of jobs available for AWS will be more compared to other cloud providers. It is being followed by Azure, followed by Google Cloud, followed by Alibaba, IBM, Salesforce, so on and so forth, right? So this pictures tells us that AWS is leading the cloud market share, and this percentage is ever growing, right? This has been growing as well as we speak, and hence our course is basically built on top of AWS itself, right? Okay, now what exactly cloud computing is, right? And what exactly AWS does for us, right? So to understand this, right, let's understand this from a story, right? The story says is there is a person who is planning to travel abroad, right, out of the country for 1 month, right? And the person has planned a trip in a way that he is going to visit various places in that country. So how he can visit, right? So to visit, he's planning to, drive a car to place visit from place A to B in that country itself. So there are two options for that person. Option number one is the person can buy a new car in that country, right? Pay the insurance, pay the registration, pay the licensing cost, right? Then, of course, drive the car for 1 month. And once he's done, he cannot take the car back to his own country because that's the law. Because the car is being purchased in that country itself, so the person has to leave the car over there, right? Option number two, guys, is the person can go and go to a renting company, right? The renting company will take the charge of number of days the person is going to use the car, not the full payment. And then the insurance and the registration fees and everything, the company will take care of. So the traveler need not to worry about the insurance costs, license costs, and everything. He or she just have to pay the price of how many number of days the person is using that car, right? So guys, if you were that traveler, which option will you be choosing? Option number one, where he has to buy the full car only for 1 month and then pay the full price, or the option number two, where he just have to go there, rent it for a few days and then come back and pay only the renting price. So which option would you like to exercise? Anyone can unmute yourself and then
Yeah, option two, of course.
option two, of course. Why? If you want to elaborate for the benefit of everyone.
Yeah, I mean, if you are renting it, it will be very cheaper.
Mm-hmm.
Okay, instead of buying it and paying for the insurance and everything, it will be very costly. That too in abroad. So it's better to rent it out for a few days and come back. I mean, by getting the benefit of it.
Absolutely right. Absolutely right. Yeah. Thank you. Thank you. What's your name? Sorry, I didn't get it.
Yeah, I'm Kulamani.
Okay. Thanks, Kulamani, for sharing this. Right. So obviously, option number two looks better for us because it's only 1 month we are traveling, and paying 1 month money compared to the fully owning the car is always a choice to make. But I'll always prefer option number two in this case. Same choice organization has to make, right? When they have to see in terms of purchasing the compute instances. Okay, now let's take a little technical dive, let's do a little technical discussion, right? So, every company has a lot of data, everyone agrees, right? So they have customer information, they have sales information, right? They have a lot of information stored. And where do they store this information? They store this information in databases, right? So where exactly they keep the databases, right? So there are two types of databases. At this moment, I'll only talk about on-premise. When I say on-premise, it means that the company has to manage that database on their own, right? So where exactly database is located? So if you see, or if you have seen it by any chance, then earlier company used to have their own server rooms, right? What the server room is? Server room is the collection of various hard disk and computers where company stores their data. What data? Again, employee information, user information, sales information, everything, right? These are very heavy servers, right? They are very costly in nature. Problem number one with these servers is that they usually get very hot because these are machines. They need to run 24 cross 7. So they are getting very hot. They need electricity every time. So company has to manage electricity. Company has to manage a cooling system for those servers. Company has to manage somebody who actually monitors the server. Imagine there is a website, right? Shopping website. And that shopping website server take cares of all the shopping items that is displayed in that website, right? On any odd day, electricity went down, there is no power backup, all of a sudden the server went down, right? Which means that it can impact my website. My website went down. All of a sudden, the users who are trying to buy something from that e-commerce website, the website went down, you cannot buy anything. Imagine how much loss the company has to face if such activity can happen, right? So they also need to manage electricity. They also need to manage the manpower to manage those servers, right? And these servers, since these are hardwares and software, so they need constantly updates or upgrades, right? You need to replace item, you need to update the software version, right? To make them virus prone, to make them attack prone, right? Lot of effort needed to manage those server. And now imagine you have to add more capacity because you are planning to launch a new, say, project, and that project require huge server because you are planning to process 100 terabytes of data for next 6 months, right? You are planning to do a one quick data analysis or ML project, and for that you need lot of data, you need lot of processing. To do this, you need to buy a lot of server. They are very costly. You need to buy manpower as well, right? You need to add additional cooling space. Lot of infra needs to be managed, right? And once it's done, what you will do with that, right? You cannot again sell it off. You have to take the burden of those heavy equipments, heavy servers at all, right? So this is one big problem that was faced by organizations over a period of time, right? And considering this problem, AWS came up with a unique solution, and that solution they name it as cloud computing. And as per the cloud computing, what AWS proposed to organization, hey, you have lot of data, you have lot of process to manage, right? You cannot buy new servers. It's very, hectic to manage servers and all, right? Why can't you give this headache to us, right? Give us all the headache of managing the server to AWS. You just worry about storing your data. You just worry about processing, right? Meaning you just worry about writing the code and logic. We will store your data secure. We will run your processing right within our cloud. You just need to worry about what code you are going to write, what pipeline you are going to build, right? So the organization says, okay, that looks a great idea, but how you are going to make my data safe? I'm giving you my precious data. How you are going to save my data, right? So they said that data safety, data availability will be our responsibility. If by any chance you see that we are not protecting your data, we are not keeping your data safe, you can, take 100x of your money back from us, right? And we are going to save and secure your data by any chance. And with that, AWS launched with their first service, and that service called as AWS S3 back in 2005, 2006. And since then, AWS has never looked back. It keep on growing exponentially, right? Top 500 organizations already uses AWS in one way or the other, either for storage, either for running big data applications, either for hosting the websites. There are various use cases in which various organizations are using AWS to serve their needs, and they take AWS cloud computing help, right? So this is basically what AWS provides in terms of cloud computing. We are going to discuss in very detail all of this stuff in our course, right? But this is just a glimpse of what exactly AWS cloud computing is and how AWS help us organization to process their data fast, to store their data more securely, right? With the increasing space, right? I see few comments in the chat. Let me first see what these are. Okay. Okay. Somebody is saying that can we apply for AWS architect job after this course? Okay, I'll take this question in the last, right? This question is very specific, so I'll park this for now. I'll take it back. Thank you for posting this. Okay. Okay, moving on. So what are the topics that we are going to cover as part of our sessions, right? So we are going to cover basics of Python and SQL, introduction to Spark, PySpark. We are going to cover all the major AWS services that we uses in our day-to-day life for data engineering, starting with IAM, S3, Lambda, Kinesis, AWS Glue, EMR, Redshift, right? Some of them have been named there, some of them are not. We have a detailed list. Ganesh can share it with you as well, right? Then all of the different topics not are only going to be theoretical in nature. All of them will be action packed with lot of hands-on practice, with mini projects at the end of each topic, with mini labs as well, right? With each topic, we are going to do real-time use case of that topic. For example, S3. So how a data engineer uses S3 in real time, in real projects, what are the use cases of S3? We are going to see that as well. We are going to do hands-on on S3. Similarly with Lambda, similarly with all other AWS services, we are going to do hands-on. We are going to practice. We are going to write codes, right? We are going to do a lot of labs out of this. Not only that, once we are done with all our different topics, we are going to do real projects that are available, open source, right? There are two projects that I am going to cover. One is going to be revolve around batch processing, and one is going to be revolve around the real-time processing, right? All of this will be covered as part of these sessions, right? So if I talk about the tools that we are going to use in our sessions, so these are the major tools that we are going to use in our sessions, right? Predominantly the hero tool for us is going to be AWS, right? We are going to learn Spark. We are going to talk about Databricks in our sessions. We are going to use Apache Airflow in our sessions. We are going to use Snowflake as well, additionally in our sessions, right, to complete the data engineering course end to end. Right here, I have a list of all those different topics in detail, like what we are going to cover in SQL, what we are going to cover in Spark, right? What we are going to cover in PySpark, Airflow, right? I'm not going to go in detail about these, right? This list you can get it from Ganesh. Keeping the interest of time of everyone on Sunday, I'll quickly want to jump on to a quick demo that way I have prepared for you guys. But before jumping to a demo, I'll take a quick pause just to see if there is any question so far coming in your mind that I can address.
Hi Aditya, sorry to interrupt. Can you please let me know what were the topics we're going to discuss on Snowflake and Databricks?
Okay. So Snowflakes we are going to use mainly for data storage. So data lake and data warehousing that we are going to cover in Snowflake. For Databricks, we are predominantly going to use Databricks for doing our Spark or say PySpark demonstrations. So all of the stuff which revolves around Spark and PySpark, we are going to cover through Databricks. But our hero component in this course will be AWS, because we are going to rely on majority of the AWS services for doing data engineering.
Okay.
Yeah.
In AWS, you will go through only in console or CLI or infrastructure as code? Any other option?
Okay. So we'll go through console, we go through CLI, we go through infra as a code.
Yeah. Okay.
So for infra, sorry to interrupt. For infra as a code, or which tool we are using? Airflow.
No, infra as a code, basically how do we deploy our services? So that's basically talks about infra as a code. So for that, we are going to use CFT, which stands for Cloud Formation
Oh,
Templates.
okay, okay, yeah.
Yeah.
Normally, for learning each of these tools, it might take around 3 months. So I'm wondering, like, how can we cover all of these tools in 3 months?
Okay, that's a very good question, right? So if you cover a tool end to end, say Databricks, so Databricks provides you machine learning capabilities. Databricks provides you more capabilities. Same thing goes with Snowflake, right? Same thing goes with Airflow. Same thing goes with AWS. AWS can do data engineering, you can do data science, you can do front end, you can do more stuff. So the way the course is designed, we are going to target the topics or tools that helps in data engineering in their day-to-day life, right? Basically, what a data engineer does, data engineer builds data pipelines. What data pipelines? It means extracting data from one source, then doing transformation, then finally loading the data back to a target. And what are the various sources from which a data engineer can extract data? It can be a real-time source, like streaming pipelines. It can be a batch processing where the data engineering is pulling data from a file or from a database, right? For doing transformation, what transformation it can do, right? For doing transformation, we can use Glue, we can use Lambda, we can use PySpark, depending upon the volume of the data that we have. And finally, where I can load my data. So I can load my data back to Snowflake. I can load my data back to uh, Redshift, or it can be again a file in S3, or it can be a data lake. So all of this ecosystem, right, wherein a data engineering fits in, that we are going to cover as part of our course, right? We are not going to cover necessary stuff that you can learn anywhere as well, right? From Google or somewhere, lot many places you can learn all of this stuff. What our intention is to give you real world focus or exposure of what exactly data engineering is all about, what real problems comes, how you use these tools to solve those real problems to build data engineering pipelines. And hence the course can cover all of this.
Meaning, like, we will only use some part of each tool and create a package of data engineering, something like that.
Okay, so AWS has 400 tools. So for data engineering, 10, 12 handful tools are utilized, right? If I can learn 400, it will take me years to complete all of them. Same thing goes with Databricks. Same thing goes with Snowflake, right? Snowflake is used for a variety of use cases. Do I need to learn other as well? I can learn, but is it useful for my data engineering? The answer is yes or no, maybe. Okay.
Hi, Aditya.
Yeah.
Parvez here. I just wanted to know that the services which we are going to use for AWS, like you have mentioned that Kinesis, Glue, S3, are they enough for going for AWS data engineering certificate?
For doing data engineering certificate. Okay. So for
AWS
doing it.
AWS data engineering.
Okay. So for whatever is required for getting a certificate for data engineering, we are predominantly going to cover as part of our course. And that's the inspiration for us as well while designing the course.
Okay, thank you.
Okay, if we don't have any further question, I'll quickly jump on to quick demo that I have prepared, right? So as part of this demo, guys, I have two use cases. One is a real-time use case, right? Quickly, I'll talk about. One is a real-time use case where I have a data coming in real time. I want to process this data in real time, meaning as soon as data comes to me, I want to process this data and store it back to a target. That is use case number one that I have. I have a data engineering pipeline demo where I am processing a batch data using PySpark, right? So here the volume of the data is large, and hence I am doing a batch processing on this data. And again, I will be extracting this information, doing a lot of transformation, and then finally loading the data back to a target, and then I'll try to generate some insights out of it, right? So first of all, I'll take the real-time, data processing. It's a very small, simple mini pipeline that I have built, right? As part of this pipeline, I have few components. I'll quickly show what those components are. So this is built using AWS. So predominantly, I have these components in this pipeline. And then finally, I'm loading the data back to. Okay. So this is one pipeline that I have for us in the demo, right? Where we have data coming in real time from a queue. Lambda is reading that data in real time, right? And then automatically processing it and loading it back to a database that we have in AWS with the name called DynamoDB, right? So let's first of all look at our database. My database contains 4 record as of now, right? It contains ID, which is a primary key in this table, age, then we have a marker, a Boolean flag, which says true and false. It's the if a person is adult or not adult, and the name of a person, right? So if I quickly look at the data that I am going to receive, right, in real time, right? So I am going to receive basically 3 fields. One is the ID, second one is the name of the person, and second one is the third is the age. So using the age, we are going to decide that whether the person is adult or not. If the age is more than 18, then the person is going to be adult. And if the person is less than 18, then we are saying that the person is not adult, right? So if you look at here, all the ages are more than 18 and hence the flag is true. And this is all will be done by the Lambda, like all the transformation will be done by Lambda, right? Now look at the quick demo here, right? Okay, let me write some information. Instead of this, I'll say 1299. I'm giving a random ID, right? I'm putting one name, maybe, I don't know, whom should I put? Let's say Mickey Mouse, right? Age of, let's say Mickey Mouse is 29, right? I'll copy this. I'll put this information, right? I'm sending this message. The message has been sent, right? So I have a Lambda function which basically reads the queue and it's supposed to load this data in real time to the database, right? Let's look at the log of this Lambda. And guys, all of this will be covered in detail in our sessions, right? As we move along. Okay. So if I look at the log, I see just one log at 9:48, which means that something has happened with my Lambda. And if I look here in my log, it says that the data has been successfully loaded, right? So the information that it is loading is ID is this, name Mickey Mouse, age 29, and it automatically identifies the adult flag as true. Let's look at our table. Okay, and yes, I do have a record with this ID and Mickey Mouse. Let's send one more record with, instead of this, let's say something else. Let's say Pluto. And here put age of 17 and ID as 1000, right? Okay, I just sent this message. Let's look at our DB. And yes, I can see the data has been loaded, right? In almost real time, right? I just pushed the message here and the data is here in the DB. It says ID as 1000, age 17, and flag for adult is saying false, and the name of the person that we have added is Pluto, right? So which basically it's a very small demo of a real-time pipeline. That's how a real-time pipeline works. Whenever you give them data, it basically processed, extracted, processed, transformed, and then finally loaded back to a target, right? So this is just one basic example of real-time pipelines that happens, right? Similarly, I have a batch data, right? So this batch data, to process this, I am going to utilize PySpark or say Spark. To run Spark, I am utilizing Databricks, right? So what exactly data we have is, right? So I have a sales data coming from an e-commerce website, right? So if you look at this data, it's a type of a semi structured data where you have, normal columns, then you have a list, right? Then again, you have a list type of column. So in this sales data, we have, sales information coming from a website, right? So which means that how a user has logged to that website. For example, if the traffic is coming from a Mac device, if the traffic is coming from Windows, if the traffic is coming from iOS, Android, right? Which phone or which operating system the user is accessing the website, what exactly user has done, have the user made any purchase, how much total quantities the user has bought, right? What activity has performed, right? When the user done this activity, it is tracked with the help of timestamp. What is the IP address of the user and the location, right? Which city the user is coming from on the website, right? And then what is the traffic? So it's a very important field which tells you that from which location the traffic is coming, whether the traffic is coming from Google, whether you have clicked the ad on YouTube and then you redirected back to the website, whether you have clicked on an ad running on Facebook and then you directed to the website, right? It's whether it's coming from Instagram, so on and so forth, right? So I have this information. It's a long data. It's a very huge data, more than million rows I have here. And from this data, I just want to understand that how much traffic is coming from various traffic sources. When I say traffic sources, I want to understand that on my website, whether the users are mainly coming from Google, mainly coming from YouTube, Facebook, Instagram, Twitter, right? I want to see which is the best traffic source for my website so that I can run more ads on that website and people can, convert more to my website, which in turns help me generate more revenue on that website, right? So using this information, I just want to see from which traffic source I am getting more users and how much sales I am getting from each traffic source, right? To get this information, right, I am using PySpark, right? And if I run this code, this is going to give me the same information back, right? Okay. So I am processing a huge data. My data has been processed and finally I got my information back, right? So if I look at this particular graph, so this graph has on x-axis the various traffic sources and on y-axis the revenue that I am generating from through each source. And if I look at the revenue, I see that directly users are coming, they are generating near about 12 million in revenue. If the users is coming from email marketing, the revenue shoots up, it goes up to 78 million, right? The revenue which I am getting from Facebook is 24 million, from Google 47, Instagram 16 million, and YouTube it's 8 million. So I know which channels through which channels users are coming and generating more revenue. So through direct email marketing, we are getting more revenue compared to any other channel, right? Similarly, if I want to understand from which channel I am getting more traffic, right? So this is all about revenue. But if I have to understand from which traffic source I am getting more revenue, right? So I also have a visualization for this. So if I look at the numbers, then the number of users coming from say directly close to 0.9 million. And if I just look at this data, I see that most of the users are coming from Google, followed by Facebook, followed by Instagram, email, YouTube, or direct, right? So this is one insight I am getting out of my sales data, right? And how I am getting all of this information by processing my raw information, right? This raw information with the help of PySpark. Why I'm utilizing PySpark here? Because the volume of the data is very large. right? It's a big data concept that we are going to learn in our courses um, going forward, right? So this is one example of batch processing that we can do and that we are going to learn, right? Okay. So these are the two demos I have planned for us for today, right? In our classes on similar line, more stuff is planned, right? That we are going to learn as well. Okay, I'll stop sharing my screen and I'll just wait for if you have any questions.
I was wondering, like after this course completion, will I be able to complete the AWS data engineering certification?
Yes, yes, you should be.
And Aditya, one more question. After completion of this course, can I be a professional who can who have like a hands-on of 2 years plus as a AWS data engineer? Can I be in such a position?
Okay, so what I am going to do, I'm going to cover in detail these topics with real-time industry experiences, right? So I have close to 7-8 years of experience. Whatever I have learned, I'm going to share those experiences with you guys as well. Now it's up to you how much you grasp, right? And how well you present during the interviews. On top of that, I'm going to share two real-time projects, right? That you can mention that you have worked on those projects because we are going to learn those projects as well.
How is the job market like for a data engineer with AWS? Like I understand like even Azure has a different market and there are something which are like not cloud, they are in-house and they use different tools. And I would just wanted to understand.
Okay, it's a good question. So, see, the market of data engineering is ever growing, right? So, only 20-30% of the organization has moved from on-premise solutions to cloud for their data pipelines. You see, still 70-80% of the organization or projects are still running on on-premise, and they needs to be migrated to cloud. And who is going to move them to cloud? Who is going to build pipelines on cloud? It's data engineers, right? Now talking about either it's going to be AWS, either it's going to be Azure or GCP, right? AWS leads this market. It has majority of the market share, followed by Azure and followed by Google Cloud.
Hi, Aditya.
Hi.
Do we require any Linux for this?
I barely understand your question. Can you please repeat again?
Do we require any Linux commanding for this?
Okay. So if I heard you correct, you are asking about Linux in data engineering. Yeah,
Yes,
we need basics of Linux that we are going to cover as well.
we are going to cover it.
Yeah.
And what is the difference between PySpark and Apache Spark?
It's same.
Same.
Yeah.
Okay.
Hello.
What would be the duration of this course, Aditya?
Okay, I take the duration question first. So duration, Ganesh can talk about on those lines, but predominantly the idea here is to cover all of these topics. And from my experience, how much time it takes near about 2 months regular classes to finish this stuff, right? And if required, we do classes on weekends as well to discuss lengthy projects, right? Because we are discussing real-time projects, then it needs a lot of discussion. So we do those kind of discussions on weekends. But Ganesh is a
Yeah.
better person to answer this question. Yeah, I'll leave it to him to answer.
Yeah, I'll talk to you, Jashwant, about this like tomorrow.
Sure, Ganesh.
I'll call each and every person like tomorrow after the demo class, and we can have a discussion about everything, about the sessions and everything, the timings and everything we can discuss.
Hello, Aditya.
Yeah.
Hi.
Yeah.
Aditya, actually, talking about my experience, actually, I am having 2 years of experience in data engineering. Okay. Prior to that, I was a PL SQL developer. So I was into PL SQL development for 4 years. Okay. But for last 2 years, I was into data engineering. But unfortunately, I did not get enough exposure into data engineering, tech stack, good tech stack.
Mhm.
So that's a big concern for me. Um, I mean, I was part of a POC, and again, I was part of one project for last 1 year where I could not get enough opportunities So talking about the market, even I am trying for a job change, but I'm not getting enough calls, to be honest. Because as I'm telling that I'm having 2 years of experience into data engineering, and the package which I'm expecting is not aligned with that, budget.
Okay. Okay.
Yeah. So that's what, because I'm not aware if the market condition is good, and if I'm taking this course, will I be able to, crack any job or something?
Okay. There are two
improve-
things that
Yeah.
you can do. One is upskills. Definitely, you can mention about good projects in your resume. And second thing is how you present your resume. Because the
course,
first
yeah.
door to get the call is resume, right?
Correct.
Secondary things comes after that, like how much knowledge you have, how you present in that interview, so on and so forth, to convert that call into a offer letter, right? So
Yeah.
one thing that we can do is improve the resume that you are presenting, and that is one exercise we can do at the end of the sessions. Okay.
Okay. So the real-time projects will be covered as part of this.
Yes, in the last, right, once we are done understanding each and every technology, then we'll discuss the real-time project so that it's easier for you to grasp that project. I can talk about that project on day one itself, but then it doesn't make sense because we don't know all of these tech stacks.
Yeah,
Right.
right.
So that's why
Mostly I
it
have
is.
worked on Azure services, but I see that many companies are asking for AWS services mostly.
Right.
Yeah.
Absolutely right. Right.
Yeah. Okay. So regarding the classes, so it will be the regular classes, right?
Yes.
Okay. Yeah. Okay. Thank you.
Yeah. Thank you.
What could be the class timings like?
This is again, Ganesh will be a better person, so we can decide by understanding the cohort preference timing, and then we can go ahead with that.
I'll talk to Abhishek about this tomorrow. Like I have to take everyone's suggestions. So based on the majority of the person's availability, then we'll go for the timings. Most by tomorrow I'll confirm the timings.
Aditya,
Yeah.
do you have any exposure for data modeling?
Okay, data modeling, right? So while going through the data lake and data warehousing, right? So I have a topic in my session which is called Redshift. So while we discuss Redshift, we'll discuss the basic practices, the basic modeling concept like star schema, snowflake schema. So that kind of stuff will be covered over there itself.
I just wanted to know that whether we are going to have this slowly changing dimensions and all.
Yes, that we'll discuss. That we'll discuss. Yeah.
Okay.
Okay, guys, if we don't have any more question, thank you so much for being such a great audience. We'll probably meet very soon. Thank you so much. Have a great rest of your evening and have a good night. Bye-bye.
Thank you, Aditya.
Thank you so much. Bye-bye.
Thank you.
Thanks, Aditya. Thanks, Aditya. Done, Ganesh.
Thanks, Aditya.
Thank you. Thanks for joining, and I'll call you tomorrow then, one by one.